C++ vectors. What can go wrong? What is a vector? A vector is simply a buffer. It implements an STL interface and usually allocates more space than we need at first. Keeping things simple, that's a vector. Not all the memory is used at first, and each element of our vector must be stored in adjacent memory. This gives us the most flexible memory access model. Let's contrast this, for example, with a list. In a list, we have a header and then our element, which is linked to another header and another element. While this adds flexibility, it has certain drawbacks. Let's look at a vector of this same list. All of our elements are right next to each other. We don't have the overhead of any headers. Depending on the CPU architecture you're employing, this might make all the difference. Vectors can be vastly superior to lists. They do have several drawbacks. For example, what about when we need more space than we have allocated? Now we run into trouble. What a vector does to handle this condition is it reallocates the buffer and copies the old data into it, thus allowing the new data to fit in adjacent memory. This can actually cause us trouble, depending how we're utilizing our vector. For example, if we had, say, made a pointer to an object that was stored in our vector, when this reallocation and copy occurs, we lose our pointer. Our pointer now is pointing to unallocated space. And depending on how the program is architected, that pointer might not know that it's not valid anymore. Vectors are not always the right tool for the job. When we use them, we should make sure that we keep track of our resize condition and element dependencies. Also, we should scope their use to avoid reallocation altogether when possible.